Okay, I had to clean up a few things. Alright, so we got our 209 thou washer in there. We got our assembly put together. We got our nut. Almost there, huh? Oh, I know what they had to take these apart before. See, when you use a regular nut in there, like this, the Allens are in the way. You can't put a socket on here. So that's why you have to take this whole thing apart to tighten the nut up and then put the bolts back in and dowels. Stupid! They could have come up with a different way of doing it. Alright, so that's all together. This, we assume is all the way tight. Where's my nut? I'm doing a full mock-up this time. It's definitely tight. Okay, so this is all tight, this is all tight. So now we don't have any more stuff flexing around anywhere. So now we take our stretch, put it in here. Remember, it doesn't work. We're hitting back here, remember? There we go. So as you put tension here, it centers it to there. So we go up, right up to it. We got to our edge there. So right now we're a little bit too far. See, I'm tightening it down here. We have a little bit of a gap right here. So that means we're a little bit too much. Let's rotate this over 180 or so. We'll check it again. Okay, it's about the same. So we have a little bit of a gap here. So this is letting the belt come out too far, which means it's going to eat on this edge. It'll chew the belt up. So that 210 is too much. So I'm thinking that 180 we had in there is probably going to be a better fitment. Okay. When you do a full mock-up, you can see stuff like this. Now that washer they had cut down right here was about 190 thou, 187, which is probably close to what we need, but I think we got a little bit more. We need a little bit more than that cut. See it quite a bit lower. And it might just work. And the reason we get a difference, see the clearance and everything? When you pull it tight, it pulls the line straight. When it's going like that up and down, everything moves. Good tight. As it comes down, it'll slightly go to the right. See right there, it moves over. So it means it's slightly inside. Turn it 180 degree, check it again. This one's barely touching, just right on that edge. Okay. So this is putting this edge here really, really close to what this is. So there's a little bit of a curve in this. I don't know if you can really see it. See how the tooth right here has got a gap in here? You put your finger on there. So that'll keep the belt from eating up on that edge also. Now the belt should be, the pulley was the same width as this one here. And we're assuming the belt is the width of the pulley, which we didn't check yet. Okay, the belt is actually a little bit narrower than the pulley. So even though we got this all lined up good, the pulley, the belt is only the width of what this cutaway is. It's not the width all the way with that gap. So that means we can pull it back in that way a little bit more. So we can take that 180 and drop back to probably about 130 to 150 at least. That way the belt is on teeth and not on air gap. So let's check our belt. Right now we know we're close to what we know these are in line perfect right now, so now we can just compensate whatever our belt width is different. Okay. First thing you do is check the belt on here. You can see the big gap in here, see? It's free to float. Now pulleys are made to have the belt track to the outside edge, which means it's going to want to go this way. That's where it's going to want to sit. So right now if it sits right there on this with our alignment, that means it will sit right up against the inside edge, or outside edge, I should say. It's going to be right up against this here. See how we got teeth hanging out? Now if we pull that over a little bit, there's actually a big undercut here, so the belt is the same width as the teeth on this pulley. Right here, same width. So we need to be 100% on there. We need to pull the front pulley over so this will ride right there we want to ride. So we got to measure the distance right there, and that's how much we need to go over. So I'll just take my calipers here. About 125 thou. So if you take that and zero it, yes. Well, you're not zeroing. What the hell's up with this damn thing? Pushing the button like crazy, nothing's happening. Well, the off button still works. The metric button still works. The alternate zero button, there it goes. No, it didn't. Confused the hell out of it. Not working. Damn, I used to use that feature a lot. Oh well. You have to do it in your head now. So that was 125 thick. This is 180. You take 180 from 125, what do you get? Or 125 from 180 is more accurate. So that leaves you only 60-something thousandths. So that's about where you should be at. Now, one thing you don't know about, it doesn't really get talked about too often, is belts like the rub right here on this taper. You eat them up. So you want the belt to come over a little bit. Not a lot, but a little bit. Alright, so I'm thinking that 93 thou washer I took out is what we're going to put back in there. That'll give me 100th thou offset. Should takes up 100,000 instead of this 125 off here. Should do what we need to do. I gotta see how I hit that washer. Looks like that one right there. $95. So 95. See, I can't make an alternate 0, but I can set the caliper. Lock it down with a set screw. Come back around. Go like that. And I don't know if you can see the caliper, but the caliper is slightly less than what the groove is in thickness. So that means the billet will run just on the inside edge of that, and which means there'll be a little bit of an edge hanging out here. Pretty close. So put this back on here again. Find a sweet spot. Damn, these are better than this. Broke it. Almost. There. Jeez, ridiculous. Can't believe it. Always had it within 3 or 4 before. There it goes. That didn't like me today. Still not going to mark it either. Be too easy. See how simple jobs takes all night? That's because you want it right, you got to do it correctly. So this time we're going to, instead of coming off this edge, we're going to come off this edge. That's the radius here. We don't have much of the straight edge to the other side, but you still get the idea. The belt is not going to be rubbing on that. So let's go off this edge over here. This is more of a straight edge. Just whenever you got a curve and something, it moves the aluminum a little bit. Okay, so I'm going to start over there. Oop. That's too much of a variable. It's too much of a variable. See, you're on a radius, so you can't get a good dimension. Can't get a dimension over here. So we have a flat surface here. So if you look to see how far you're off on this side, that's how far it moves in on the other side. So you can see it's a good 100th thou, it looks like, or about 80. So that means you're going to be 80 to 100 thou inside of that groove. That's an 1/8 inch thick. So just like I figured, the belt's going to be just on top of that on this side. That's if it's all the way against this edge here where it belongs. Now if it goes the other direction, it's going to eat on the primary cover in here. Next to the belt, it's supposed to track to the outside edge. If it goes to the inside, it's going to eat itself up. If it goes on the outside, we're fine. Just a matter where it tracks. It's supposed to track to the outside. So the way they make it do that is they make it, this is actually cut on a taper. It's bigger on this side than that side. Belts, ropes, whatever you do, they always go up to height like this with a pulley. Cut at an angle like this. It's thicker here than here, bigger diameter. It's always going to ride at the very top. That's how they work. Belts, chains, they all do the same thing. They all want to go to the high spot. For some reason I like running uphill. I don't know why, it's just how it is. I'm sure somebody will make a comment and tell me why it does that. But that's just how it is in the real world. Okay, so now appear to have everything figured out. Right back where I started. No, it goes this way, dumbass. See, I tell you with 2 hands, it takes 2 hands to get it off now. Okay. And the last thing I want to do is I want to make sure the belt's not going to get caught on anything. See, look at all these edges here. Make sure there's nothing sharp hanging out like that. Or in our case, we have all this damage up under here. This is the kind of stuff you don't want your belt getting into. So I'm going to file that down a little bit. This edge right here will probably never catch a belt because it's such a small diameter. But you can always knock this edge down a little bit with a file too if you want, just in case. But it's not likely it'll ever touch it. Because to be that far down, your belt would have to hang way down there to hit that. Be really loose. And belts want to go up like this, they make a curve like this. Because once you got something bent, it wants to stay bent even though it's free. It doesn't go the other way. People think it will, but it won't. Look at a rear chain on a bike sometimes going down the road. You can see what arcs and stuff things want to be. Okay, so now, where'd that file run off to? We're going to take away a little bit of material here. Try to catch some of it. Okay. Gone. Maybe a few chips in there so I blow out the airline. I think I got most of it out. Snagglepuss is no longer snaggling. It's all gone. Ready stuff. Took the edge off the flat surface even though it doesn't really matter. So, should be pretty good. Alright. Put a bunch of marks in there. So this should be time to go together. Should be anything else wrong? Dirt right there, belt residue. Final wipe down. Not sure if I was filming there, but I wasn't paying attention to what I was doing. Again. Alright, so now we're ready to go together. Okay. Be right back. Be back in a minute.